Hey everybody, today we are going to talk about surface area of pyramids. In the next video we'll talk about surface area of cones. A pyramid is a polyhedron in which the base is a polygon and the lateral faces are triangles with a common vertex. Okay, so here we have an example of a pyramid. Here is another example. So we've got a pyramid here with triangular lateral faces and a square base. And here we have triangular lateral faces and a triangular base. All of those triangles come together at a common vertex. Same here, all four triangles come together at this common vertex. Okay, now every corner on this polyhedron is considered a vertex. But typically on a pyramid, this one right here where the triangles meet is called the vertex. So even though they are all vertices, the one where the triangles meet is typically called the vertex. So the common vertex of the lateral faces, the triangles, is considered the vertex of the pyramid. A regular pyramid is a pyramid whose base is a regular polygon and the segment connecting the vertex and the center of the base is perpendicular to the base. Okay, so that means that if I put a vertex or a segment from this vertex to the center of the base, it would look about like that. That segment there is perpendicular to the base. That is called the height of the pyramid. So the pen right now is representing the height of the pyramid. It is perpendicular to the base. The lateral faces of a regular pyramid are congruent isosceles triangles. Okay, so that's the case on both of the pyramids I have shown you. We've got 4 of them on here. They are congruent and they are isosceles. And once again, the segment from the vertex to the center of the base is perpendicular to the base. That is the height of the pyramid. The slant height of a pyramid is different. That is the height of a lateral face of a regular pyramid. The slant height is important in finding the surface area of a pyramid. The slant height looks like this. It goes down the side of the pyramid and it is perpendicular to that base. The lateral surface consists of all lateral faces and excludes the base. So if you just need to know the lateral surface of any polyhedron, you use the lateral faces, but you do not use the base in that lateral surface. So the surface area of a regular pyramid is found like this. Capital B, which stands for the area of the base. And there's only one of them, so it's not 2B like in a prism. Plus 1/2 times perimeter times slant height. Okay, so the P is for perimeter, and L is for slant height. Okay, so the capital B finds the area of the base. 1/2 times perimeter times slant height finds all the triangular faces all in one move. Okay, so a triangle is 1/2 times base times height, and this perimeter, what it does is it finds all the bases together, puts all those bases together, and does 1/2 times base times height for all the triangles in one move. Okay, so in a pyramid, here's your base. That capital B just means put in the area formula for whatever shaped base you have. Okay, then perimeter is all the way around that base. And then slant height is this length right here. Okay, so let's find the surface area of some pyramids. So here we have a square base, so this is a square pyramid. So the surface area is area of the base. Now for a square, that would be side squared. So the area of this base right here, this square base, is 6 squared. Plus the half of the perimeter. So the perimeter is 6 times 4. There are 4 sides, all the same. They are all 6. So for the perimeter, we'll put in 6 times 4 times the slant height, and the slant height is 8. So we'll put that all in our calculator. 6 squared plus half times 6 times 4. 6 times 4 is the perimeter, times the slant height, 8. And we get 132. And it's in inches, so the surface area is 132 inches squared. Here we have a triangle, and it happens to be equilateral. Okay, so the surface area is the area of the base, so that's 1/2 times base times height. I'm going to redraw this triangle from more of a straight-on view. Okay, so it looks like this from a straight-on view. So in order to find the area of this triangle, 1/2 times base times height, I will draw in a height of the triangle. And we're going to need to find that height. Okay, so the base right here is 100. So I'll put that in. So there's 1/2 times base, but we need height. So for the height, since I've split this in 2, I'll put 50 here and 100 here, and I'm going to use Pythagorean theorem to find the height. So 50 squared plus h squared equals 100 squared. So that's leg squared plus leg squared equals hypotenuse squared. So let's do minus 50 squared. So we get h squared equals 100 squared minus 50 squared is 7,500. And then the square root of 7,500 is 86.6. Okay, so for the height of this triangle, we have 86.6. Okay, so there's my half base times height. So that is the capital B. That's the area of the base. Plus 1/2 times perimeter. Perimeter is 100 times 3 times the slant height, which is 80. So we have 0.5 times 100 times 86.6 plus 0.5 times 100 times 3 times 80. And that is 16,330. So 16,330 meters squared is the surface area. Okay, now we're only dealing with regular pyramids here. So this one does not have tick marks on it, but because I'm telling you it's a regular pyramid, that means this is a square right here. So the surface area is area of the base. It's got a square base, that's side squared, so 8 squared for the area of the base, plus 1/2 times perimeter. There are 4 sides to this base, each one is 8, so that's 4 times 8 for the perimeter, times the slant height, which is 13. So 8 squared plus 0.5 times 4 times 8 times 13 is 272. So we have a surface area of 272 inches squared. Here we have a pentagon, so we will use the regular polygon formula. So the surface area is, and for a regular polygon, the area is 1/2 times apothem times perimeter. Okay, so the surface area, capital B, area of the base is 1/2 apothem times perimeter. That's 1/2 times, here's the apothem, 4.1. Times the perimeter, there are 5 sides, each one is 6. 5 times 6 is the perimeter. Plus 1/2 perimeter times slant height. So that's 1/2 times the same perimeter, 5 times 6, times the slant height, which is 9. So we have 0.5 times 4.1 times 5 times 6. That's 1/2 apothem times perimeter, plus 1/2 times perimeter times slant height, 0.5 times 5 times 6 times 9. And we have 196.5 feet squared. Okay, so we have 2 more, and then we will talk about cones in our next video. So this time we are given that the lateral area is 70 feet, and that should actually say 70 feet squared. Okay, so the lateral area is 70 feet squared. We want to find the slant height. Okay, so the lateral area, we talked about a little bit, it's everything except the base. So no base, it's just 1/2 perimeter times slant height. Okay, so the lateral area we're given is 70 equals 1/2 times perimeter is 7 times 4. There are 4 sides, each side is 7, so the perimeter is 7 times 4 times a slant height that we do not know yet. Okay, so 1/2 times 7 times 4, let's simplify that. That is 14. So 70 equals 14 times the slant height. And we can divide by 14. So 70 divided by 14 is 5. So the slant height is 5, and the units are feet. And here's one more example where we want to find the slant height. Okay, so I'll draw in a slant height right here. Okay, so what I'm going to do is actually make a right triangle out of this. Now if this side is 10, then this right here is 5. Okay, so that's halfway across this square. So to find the slant height, we could do 9 squared plus 5 squared, that's leg squared plus leg squared, equals the hypotenuse squared, and the hypotenuse here happens to be the slant height, so the slant height squared. So we've got 9 squared plus 5 squared, and that is 106. Okay, so now we can try to simplify this if we can. When we do the square root, we can try to leave it exact, or we can put it in decimal form. Now if we want to leave this exact, okay, so what multiplies to make 106? There's 53 times 2, and I'm not going to be able to break that down any further, and there's no pairs. So the square root of 106 would be an exact answer, and that is in, units are not given here, so 100 square root of 106 units. Or we can find the approximate answer by finding the square root of 106, and that is 10.295, so about 10.3 units. So we have an exact answer and an approximate answer here, and either one will do.